Now, before we get to our next example, it reads, the graph of an equation and the variables x and y represent a relationship between a real number x and a corresponding real number y. Therefore, the values of x must be chosen so that when substituted into the equation, they produce a real number for y. Sometimes the values of x must be restricted to produce real numbers for y. This, in our notes anyway, was demonstrated in the last example. Remember when we had our little chart of x, y ordered pairs? We didn't let x be 0 because y was not defined for our real numbers. 1 over 0, we don't know what to do with that. Okay? Sometimes we're going to need to restrict a variable so that we don't get 0 in the denominator, or we don't want any imaginary numbers because we want real numbers. So we don't want to pick out any values of x or y if we need to that will give us 0 in the denominator of a fraction or a negative under a square root, because that would give us an imaginary number. And I don't know where imaginary numbers go on our real coordinate plane. Now on example 5, number 40, we have the equation y squared minus x plus 1 equals 0. It is handy whenever possible to solve for one of the variables. Now, if I try to solve for y every time, that's going to be pretty ugly. Now, I could say y squared, add x and subtract 1 from both sides, and you would have y squared equals x minus 1. Then to solve for y, take the square root of both sides, and now I've got a big mess. You don't have to do that. This would work, but what you might rather do is solve for, instead of y, solve for the variable x by adding it to both sides. Now our equation looks like y squared plus 1 equals x. Or, if we want to write it kind of as a formula, x is equal to y squared plus 1. I'm going to look at either one of those two forms, probably the one I'm drawing a puffy cloud around, to then generate my xy ordered pairs that are going to satisfy that equation. Now, oftentimes we get so bogged down in thinking, oh, I got to pick out values of x, plop them in my equation here, and find the corresponding y values. That's not true. You do have the option of picking out values for y, squaring those and adding 1, and that gives you your x values. So down this column, since I have my equation solved for x, I'm going to pick out y values, such as 0, okay? Let's do a negative 1. Let's do a positive 1. Let's do a negative 2. Let's do a positive 2. That's not a positive 2. That's a positive 2. Let's do a negative 3 and a positive 3. Hey, and if we need to go back and pick out some fractions and some decimals and some bigger numbers, we sure can. All right, now use your formula here to calculate the x values given these chosen y values. So our formula says x is going to be equal to the y value squared plus 1. So 0 squared is 0. When I add 1 to that, x is 1 when y is 0. Okay, the next relationship is what is x when y is a negative 1. So I'm putting my chosen values in for the y, squaring them, adding 1 to it. So now my equation says x is equal to negative 1 squared is positive 1 plus 1 is 2. Okay? Now, a little shortcut here is if you notice that when y is a positive 1, when we square that, we also get the same number 1. 1 plus 1 is still going to be 2. That's 2 also. All right, moving on to the next value for y of -2. Using our formula in the puffy cloud, x is equal to the y value squared plus 1. This time when I square the y value of -2, I get 4, and 4 plus 1 is going to give me 5. Quick edit here. When y is now a +2 and I square it, I still get 4, and 4 plus 1 is still 5. I like that squared thing. That's kind of nice. For the values of -3 and also what's going to happen with +3 for y, my formula says x is equal to the y value squared increased by 1. -3 squared is 9. When I add 1 to that, I'm going to be getting 10. And when x is a +3, like in my last scenario, when y is a +3, x is still 9 when we square it, plus 1, 10. Now, come over to your graph paper and plot those points. With the way that this particular graph paper is set up, I don't have quite enough room unless I rescale my axes for that point for x of 10, -3, and 10, +3. I'll visit about that here in just a minute. But let's plot the rest of these. Let's first of all plot 1 for x, 0 for y. 1 for x, 0 for y. Right there. Now, let's look at 2, -1. 2 for x, -1 for y. Let's also plot 2, +1. 1, 2, +1. That's 2, 1. Next, let's plot 5 for x, -2 for y. So 1, 2, 3, 4, 5 for x, -2 for y. And also 5 for x, +2 for y. And like I was saying, 10, -3, we'd have to keep that in mind where that is. We'll head toward that direction. 1, 2, 3, 4, 5, 6, 7, 8. I'm off my graph paper. But 9, 10, up 3 and down 3. What we have going on for our graph here is a little parabola that is opening to the right. If you want to find some more ordered pairs, you can. You might want to let your y values be some decimals or fractions. Again, label the graph with its equation. Either form will work, okay? Or if you're working on your homework, you might want to say this is number 40, which was, let's see, y squared minus x plus 1 equals 0. Or you could label it with the form we have over there in the cloud. Either way.